Hello students and welcome to Chemistry B. I'm Ms. Sleight and today we're going to be talking about how we can predict the products of certain reactions. Specifically, combustion, single replacement, and double replacement reactions. To begin with, we're going to start with combustion reactions. Anytime a hydrocarbon undergoes combustion, the products will always be carbon dioxide and water. And a hydrocarbon is any compound that's made of just carbon and hydrogen. So our examples below, C3H8, that's a hydrocarbon, plus O2 means combustion. The products have to be carbon dioxide and water. If you have a hydrocarbon undergoing combustion, products, carbon dioxide and water every single time. That's the easiest one to predict products for. Next, we need to talk about single replacement reactions. And single replacement reactions is where you will need your activity series. It's one of the sheets that you are given in class. The activity series is a chart that ranks the relative reactivity of different metals. And the metals at the top are the most reactive and will be able to replace metals below them in a single replacement reaction. So let's look at some examples here. First off, we have aluminum being combined with copper 2 chloride. Well, if we look at our activity series, aluminum is above copper on the series, which means it can replace it. So this reaction will occur, and you'll see aluminum and copper swap places, and that means our products will be copper metal and aluminum chloride, like a regular single replacement reaction. Next up, we have nickel combined with sodium chloride. So we're going to look at our activity series again. This time, nickel is below sodium. So that means nickel is not more reactive than sodium. So it cannot replace sodium in the compound. So this reaction will not occur at all. Because in order for one of these reactions to take place, the plain metal that you're starting with has to be more reactive than the metal that is already bonded in the compound. So let's look at our third example, lithium combining with zinc carbonate. Well, let's look at our activity series. Lithium is indeed above zinc, so it is more reactive than zinc and can replace it in a reaction. So this single replacement reaction will take place. Zinc and lithium will trade places, and our products will be zinc metal and lithium carbonate. Make sure that when you're writing the formulas for these ionic compounds that you're taking into account the ion charges so that you're writing the correct formulas. Lastly, let's look at a single replacement reaction that's a little bit different. Here we have iodine combining with sodium chloride. So iodine's not a metal, it's a halogen. Well, there also happens to be a reactivity series for the halogens. So let's look at that one. If we look here, no reaction is going to take place because iodine is below chlorine in the reactivity of halogens. So the reactivity for halogens works the same way as the metals. In order for a halogen to replace another halogen, it needs to be above it on the reactivity series. Lastly, let's talk about predicting the products of double replacement reactions. In order for a double replacement reaction to occur, one of the following things must take place. A precipitate or a solid product must form, water must form as a product, or a gas must form. So in order to figure out if one of these things happened, one of our main tools is the solubility chart. So this should be on the other side of the activity series that you were given. And we can use it to figure out if a compound is going to be aqueous, dissolved in solution, or if it will come out of solution and be a solid. So if two ions on the solubility chart come together to be soluble, that means in the equation they will be aqueous for their state of matter. If two ions come together and they are insoluble or partially soluble, they will come out of solution and their state of matter will be a solid in the reaction. So now let's go through some examples of this and see how this will work. So our first example for predicting the products of a double replacement reaction is sodium chloride combining with lithium nitrate. Both are aqueous. So in order for this reaction to occur, one of the products must either be a solid, water, or some kind of gas. So what we're going to do is we're going to figure out what would the products be, and is one of them going to be a solid, water, or a gas? If none of that is true, the reaction won't occur. So if this is indeed a complete double replacement reaction, we know that sodium and lithium are going to trade places. So we're going to end up with lithium chloride at the end as one of our products. Let's pull out our solubility table and we're going to figure out if this is going to be aqueous or a solid. So here's how I would do this. I would find lithium on the side, there's lithium, and then at the top I would find chloride, and if I come together they form an S, so they're going to be soluble, meaning they will be aqueous in solution. So then our other product would be sodium combining with nitrate, so that'd form sodium nitrate. And now I need to do the same thing with my solubility chart to determine if this is going to be solid or aqueous. So I'd find sodium, and then at the top I'd find nitrate. This is also going to be soluble, meaning it would be aqueous. What this means is this reaction will not occur. This is NR no reaction. Because remember, in order for a double replacement reaction to take place, one of our products must be a solid, water, or a gas. Let's look at another example. Let's look at ammonium sulfide combining with lead nitrate. So again, if this is going to be a double replacement reaction, the ammonium ion and the lead ion are going to trade places. In this case, this is a lead +2 ion. So let's look and see what those products would be. So we would have ammonium coming together with nitrate. Ammonium is NH4 with a +1 charge. Nitrate is NO3 with a -1. So they would combine in a 1-to-1 ratio. So I'm going to pull up my solubility chart. And ammonium, and then I got to find nitrate. They are soluble, so their state of matter is going to be aqueous. And then my lead ion would be combining with sulfide. Well, it's lead +2. Sulfide always forms a -2 ion. So they would also combine in a 1-to-1 ratio to form lead-2 sulfide. So now again, I need to pull out my solubility chart. I'm going to find lead-2, and then I need to find sulfide. It's all the way at the end. They are insoluble, so that means they are going to form a solid. And because this is a solid, that means this is indeed a complete double replacement reaction. Let's look at one more example. In our third example here, we have sulfuric acid reacting with sodium hydroxide. So if this is a double replacement reaction, our hydrogen ion and our sodium ion will trade places. So we're going to have sodium combining with sulfate. Remember, sodium is a +1 ion. Sulfate is a -2. So I'm actually going to need 2 sodium ions when I write the formula. Na2SO4. Then we're going to figure out if this is soluble or insoluble with our chart. So I'm going to go down to sodium. I'm going to find sulfate, second to the end. It is soluble. So its state of matter is going to be aqueous. Then we have our hydrogen ion, right, combining with our hydroxide ion. So positive in one and negative one, they'll combine in a 1-to-1 ratio. Notice, though, what does this remind you of? 2 hydrogen atoms and 1 oxygen. It kind of reminds us of water. When a hydrogen ion combines with a hydroxide ion, they will form water. So our other product in this double replacement reaction is going to be water, which of course is going to be a liquid. So this is also a complete double replacement reaction because, again, one of our products is water. So this wraps up our discussion of how to predict the products for different reactions. Have a great rest of your day, and I'll catch you next time.